Stacks are one of the simplest, yet most powerful data structures. It powers some of the most critical features in software today. Let's dive in to see why stacks are essential for software development and why you can't ignore them. First, let's talk about what a stack actually is. Think of it as a collection, where you add elements one on top of the other and remove them in reverse order. Last in, first out, or LIFO for short. This structure may sound simple, but its applications in software are huge. Let's work with this simple list, 10, 20, 30, 40, 50, and perform some basic stack operations using LIFO. Imagine this list as a stack, where 50 is at the top. Now, let's see what happens when we perform some stack operations. Push operation. First up, let's push a new item. Let's say we want to add 60. Pushing adds it to the top. Now our stack is 10, 20, 30, 40, 50, 60, with 60 at the top. Pop operation. Now let's pop an item. Pop removes the top item from the stack. So, in this case, 60 will be removed. After popping, our stack is back to 10, 20, 30, 40, 50, with 50 now as the new top item. Peek operation. Next, let's peek. Peeking lets us see the top item without removing it. Right now, our top item is 50. Peeking confirms that 50 is at the top of the stack. Is empty operation. And finally, let's check if our stack is empty. We still have items in it, so the result is false. So why do stacks matter? For starters, they're crucial in everyday software functionalities. From that undo button in your favorite editor to navigating back on your web browser, stacks make it possible by keeping track of actions in a specific order. Stacks are also at the heart of something called function call stacks. When you call a function, it's stacked on top of the previous ones, so the software always knows where to return once each task is done. This is essential for managing tasks that rely on other processes, like recursion. Is it always the best choice? Stacks can be limiting, or even a bad choice in certain scenarios. When it comes to large data handling, or where order isn't as strict, other data structures like queues or trees might perform better. So, stacks aren't a one-size-fits-all solution. That's why, as developers, it's crucial to understand the strengths and weaknesses of stacks. So, next time you hit undo or backtrack in an app, remember, you're experiencing the power of a stack in action. Like and subscribe for more deep dives into the essentials of software engineering.